I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, Going Beyond Relational Data with Microsoft SQL Server 2008. Now it is my pleasure to introduce today's presenter, Sean Sinha, who is a Program Manager with Microsoft. Sean, you now have the floor.
Thanks, Heather. Hello, everybody. I appreciate the time that you're spending here with us. I'm excited to tell you about many of the features that we're building into our next release of SQL Server 2008. It's going to be a very big release for us. We're very excited. I think it was made public just recently that we will be launching SQL Server 2008 in February of next year. And I hope with this presentation today, I'll be able to give you at least a partial sense of some of the great features that we are building into the product. The specific theme that we're going to focus on here today is something that we're calling Beyond Relational, and I'll explain a bit more about what we mean, and look forward to your questions and comments that come up over the course of the presentation. So, as Heather said, feel free to post your questions into the question manager through live meeting. What I'll do is at the end of the presentation, I'll start combing through those questions and answering them verbally for everyone to hear. So before we get started, though, this is a new format for me and for many of us here inside Microsoft here to do the webcasts. So what I would like to do is get just a very quick sense, ask all of you a quick question or two to get a quick sense on a couple of things so that we can level set the presentation and make sure that we're giving you the appropriate content. So the first question I have is just, can you describe generally what your role is and what sorts of things do you work on? I'll give you a couple of minutes. All right. Looks like we are mostly DBAs and developers, a handful of architects and strategists, and a few IT managers and IT administrators to go. I'll go ahead and show the results. All right, and one more question. Are you currently a customer? Are you evaluating SQL or not even considering it? All right, great. Great to see so many customers here interested in the next version, and good to see the few of you that are looking at using SQL in your environment. I'll go ahead and keep moving on. Let me tell you a bit about what you are going to see over the course of the next hour. What I want to start by doing is giving you an overview of SQL Server 2008 at a very, very high level in terms of what our key release themes are. I'm going to give you an overview of what we mean by Beyond Relational. And I want to talk about a class of applications that we really think about that motivate our Beyond Relational scenarios. It's a class of applications that we're calling information-centric applications. I'm going to give you a high-level feature overview of everything that we're building into the product to deliver on our Beyond Relational vision. And then I want to give you a whirlwind feature tour of all of each of the features that I'm going to describe here, which is just a subset of all the features that we're building into the product. And then finally, I'll open up the floor to Q&A towards the last quarter of the hour. All right. So let's start by talking a bit about what SQL Server 2008 is about. When we think about SQL Server 2008, SQL Server is just a core component of a number of products that we're delivering to enable all of the scenarios that your applications and your enterprises need. So SQL Server works with our SQL Server combined with our developer platform in .NET, our developer tool suite in Visual Studio, BizTalk Server for workflow, and Microsoft Office for your front-end client and analysis work really forms the core of what we look at as the enterprise offering around delivering and deploying the best applications and the applications that you need. When we think about the storage layer for us spans all tiers of the spectrum. That ranges from the mobile devices that that your workers and your employees use, up to the desktop and the client, all the way up into the server side, and all the way up into the cloud. When we think about all of those different tiers of where data can live, what we want to do is, or what we aspire to do, is create a data platform that can host all these different types of data: structured, unstructured, semi-structured. That means things like your traditional relational database systems, semi-structured data, things like XML, unstructured data, things like files, and then your higher level data objects, things like OLAP cubes and analysis services and all of that. And then on top of that, what we see here, this is all on the diagram on the right side of the picture here, is a rich set of services over all of that data across all tiers of data storage. And what we mean by all those services, we're talking about things like querying, analysis, reporting, integration, synchronization, and search. Our goal is to deliver a common set of services over all these different types of data, spanning all tiers of storage. So when we think about SQL Server 2008, or when we think about SQL Server period, we bucket all of our features into 4 enduring themes that we continue to iterate on over numerous releases. And in 2008, we made a number of strides toward each of these release themes, but I want to describe to you here what each of those release themes are, and then for the rest of this discussion, we'll focus on the particular topic for today, which is beyond relational. The first key release theme is something that what we're calling is the enterprise data platform. SQL Server is truly meant to be an enterprise-ready product, and when we think about what it means to be an enterprise-ready product, it's really about the fundamentals. This means scalability, availability, reliability, security, all of those fundamental concerns that create an enterprise product and are required for all of your applications. SQL Server is delivering on a number of features that will expand upon the improvements that we made in our previous release in 2005. Beyond relational, the topic of this discussion, is about the sets of features to really enable the data platform to host all different forms of data: structured, semi-structured, and unstructured. Dynamic development is really about our investments in the entity data platform. The entity data platform is about enabling developers to create applications at a higher level so that they can create apps in terms of objects like products and customers and orders, rather than having to worry about the specific low-level details like rows and columns and specific data types, etc. And then finally, we know one of the biggest drivers for SQL Server is our BI capabilities, our business intelligence capabilities. We know that reporting services and analysis services have become very, very critical features to the SQL Server experience. And in 2008, we're making a number of investments. Toward delivering on our BI capabilities that we delivered in our previous version in 2005. All right, so let me move on. Let's drill down into what beyond relational really means. So when we think about beyond relational, what we've seen is that there's a new class of applications that are becoming much more common. And these applications are being driven by the extreme decrease in the cost of storage. I think everybody here knows that the storage costs have dramatically fallen in the last several years. And what that means is that there's been an explosion of all these different forms of data. Almost 5 to 10 years ago, it would have been unfathomable for us to have anywhere near a terabyte of data. But today, I would imagine that almost everyone here probably has a terabyte of storage within their homes, much less within their enterprises. So what that's really led to is more and more forms of data being stored digitally. And what that subsequently is leading to is more complexity in building applications that use all of these different types of data. I'd like to point to a concrete example here. Let's take a look at the insurance claims application. So an insurance claims application of 10 years ago was probably little more than mapping a number of forms into rows and columns in a database and being able to do relatively simple queries. But let's think about the insurance claims application of today. Not only do you have that same set of forms-based data stored in rows and columns in your database tables, but you also have things like documents and audio files and multimedia files and pictures. So you might have pictures of your car accidents or videos of witnesses and witness testimonies, or you might have documents that represent your insurance claims records. But all of those unstructured types of content need to be associated to the insurance claims record that lives inside your database. You might have location-aware features within your insurance claims application, so that you can map out where insurance claims are being filed at the moment, where are the highest peaks of demand. And then finally, you have all of these applications working in a more complex IT environment requiring data to move around between systems, oftentimes interchanged in XML or some other semi-structured format. The interesting observation here is that all of these different applications, there are many such applications like this insurance claims application, and what we strive to do with SQL Server 2008 is take a number of steps toward making the creation and management of those applications a lot easier and a lot more effective. And what we'll do is we'll talk about the features that we're building toward that end, and then we'll even give you a demo of one of those features and look forward to you using the CTP to give us feedback on how all these features work in the future. So let's talk a bit about what kind of challenges we've identified as we see these new types of information-centric applications being created. At the end of the day, what we've observed is as applications have needed to use more and more different types of data, things like relational data, location-aware data, spatial data, documents and unstructured documents, what we've observed is that there's an increasing complexity in the creation and management of all those applications. Most of that stems from the fact that there lacks a uniform set of services available over all of that data. So if I think about my relational tables, for example, I have capabilities like transactions and support for large data sets. I have security features to ensure that I have the right privileges implemented. I have rich search and querying capabilities. I can layer my BI services on top of that. But as I look at the other forms of data that your applications might take advantage of, there's friction that is created by having different sets of services that are implemented in different ways across each one of those different forms of data. As a result, that leads to greater complexity in management, greater complexity in deployment, and greater complexity in development. So what that boils down to is, in our view of the world, Beyond Relational really translates three key pain points into a set of goals that we have for SQL Server that we plan to deliver on in a big way in 2008. The key pain points revolve around A, the complexity of just dealing with and managing relational and non-relational data. That means your unstructured data, whether it lives in your database or elsewhere, your structured data that lives in your database, or in the numerous interchange formats, things like XML, things like spatial data, all living in separate, disparate systems. That's translated into a huge pain around the growth in application complexity, which leads to a number of duplicated types of capabilities. Oftentimes querying capabilities and reporting capabilities are re-implemented. And what that translates to is major problems associated with development and deployment. And then finally, developers and IT administrators and IT managers alike have to compensate for the unavailable services or for the lack of services, the lack of uniform services available over all those different types of data. Backing up your documents is oftentimes a different process from backing up your databases. So with SQL Server 2008, our goal is to really reduce the cost of managing all these forms of data. It's to simplify the development of applications and it's to extend a set of uniform services available over all those different types of data. So let's translate that into a set of features that we're planning to deliver for each of these different forms of data. As you can see, in 2005, we made some big steps toward achieving this vision by investing in a big way in our native support for XML data in the database. We made some substantial improvements to the full-text indexing capabilities, and we introduced our first notion of extensibility in the database by introducing a concept called user-defined types, which allows you to extend the functionality of the database and the types of data it can support. Well, as you can see in 2008, across all these different forms of data, we've made some very, very major improvements, or very major investments on each one of these features, and this ranges from upgrading the XML support we built on in 2005 to much greater support for unstructured content. We've introduced spatial support, native spatial support for geography and geometry data types, and we've created a number of new features to enable more flexibility around how you store your structured data so that you can take advantage of different data models on how to store some of that structured data. And we'll walk through each one of these features, and I'll give you a demo of one of our features around the storage of unstructured content. So let's start by talking about one of the biggest areas of investment that we've made in 2008. It's around the use of blobs in your applications, and what we're calling unstructured data is oftentimes just stored as blobs in your database, or oftentimes in a number of different other ways. What we observed is there are three core scenarios, or three scenarios that people typically utilize whenever they're deploying and creating applications that make use of blob data, things like your files and documents, and that make use of unstructured data. The first option that we've observed is oftentimes the blobs are stored on file servers and your structured data is stored in databases. The second option that we've seen is those blobs are stored in dedicated blob stores, things like EMC Centera or Fujitsu Nearline, systems that offer different types of capabilities around the management of those blobs. And then again, the structured data is stored in the database. And then the third scenario we've seen is the storage of the blobs and the structured data all in the same location within the database. All these options have their own trade-offs and advantages. Oftentimes the file servers are used to achieve lower cost per gigabyte for your blobs. Dedicated blob stores are used to achieve very low cost once you achieve a certain amount of scale. Oftentimes you get capabilities like hierarchical storage management, etc. And then oftentimes you'll see people store blobs and structured data directly in the same database, so you get the management benefits of integrated storage, so that capabilities like transactions and backup and restore and services like those continue to work in a very, very seamless way. So let me ask the audience very quickly here, and I'll show the results here. How many of you are storing your blobs for your particular application, storing your blobs and your structured data directly in the database? How many of you are using file servers and to store your blobs, or dedicated blob stores to store your blobs and storing your structured data in the database? And how many of you are using both and have examples of both? All right. It looks like it's split pretty evenly, and it's interesting because I did a very similar straw poll at TechEd. I'm not sure how many of you were there, but at TechEd the audience was split into three, across each of those different scenarios, and it looks very similar here. So clearly, there's a need to support all of these different scenarios, and with SQL Server 2008. We're expecting to deliver on each one of those scenarios. We don't prescribe any particular benefits. We know that depending on your different application architectures, you have different unique requirements that will drive you towards one design or another, And our goal for SQL Server 2008 is to enable any one of these scenarios to be a really, really great experience. So what are we doing? Well, if I can switch the slide here. There we go. So in SQL Server 2008, we're adding two new capabilities around the storage of blobs, around the storage and use of blobs. In the past, what we typically depended on is our var binary column to store all of your blobs. And what that ultimately meant is all of your blobs were stored in line with your databases, but you also incurred the overhead of all those blobs having to be processed through the database querying engine in order to be streamed out of the database into your applications. So what we're doing in 2008 is investing in two features. One is something that we're calling file stream. File stream is all about improving the way that blobs work when they're stored directly in the database. And namely, this revolves around performance. We know that there's a performance hit that you take by storing your blobs in the database. And what we've done is move those blobs out of the database, stored them in the file system in order to improve the performance. The second area of investment that we're making is something that we're calling the Remote Blob Storage API, or RBS. You might hear me refer to it as by its acronym. What the Remote Blob Storage API revolves around is giving you the ability to store your structured data in the database and store your blobs in a different provider-agnostic way into a store that makes the most sense for your blobs. What the Remote Blob Storage API will give you is the ability to maintain the links between the structured data and the blobs to which they refer, do the garbage collection, and offer you a level of consistency that you typically have to create on your own if you adopt an architecture that looks something like blobs living in one place and structured data living in your database. So let me first start by giving you a few details of how our file stream solution works. File streams are all about improving the use of blobs directly in line with your database. What we've done is implemented a new storage attribute on var binary max columns that tell the database to store the blobs inside the database as files in the file system. What that means is that when you retrieve the blobs out of the database, those blobs can be streamed out of the database at the speed at which the file system can stream that file back out to the client. That obviously gives you all the performance benefits and the performance enhancements that go into the file system layer without requiring the overhead of working through the database system. What we've done is created a dual programming model to enable these scenarios so that you can access your blob data either through your T-SQL APIs or through a set of Win32 APIs. And what that means is I can use open file, read file, write file on each of those blobs directly in my application through the Win32 APIs. On top of that, because file streams are implemented as a kernel driver in your OS and implemented directly in line with the database, we deliver something that we're calling data consistency. Essentially what that means is we have integrated management capabilities. Transactions are supported. So if I write and make changes to my file, those transactional, those updates will be done within the context of a transaction. I get my administration and backup restore capabilities on the entire row, which includes the blob. And the size of the blobs is limited only by the file system volume size. And then finally, the security privileges associated with those blobs is managed and controlled directly by the SQL Server security model. So if I secure a particular table that stores these blobs on the file system, the security privileges, the ACLs, will be mapped down into the file system object, so only the privileges that are granted on the table will be enabled on the blob objects themselves. So it's a substitute for SQL Server blobs in a very, very high performance kind of way. So instead of talking more about it, what I'm going to do is switch over into a demo of how this file stream feature will work. It's not going to be the sexiest demo in the world, but it should give you a sense for some of the possibilities of how file streams could be used in your application. I'm going to switch over to sharing my desktop. I see a number of questions coming up. One of the questions I see here is, what does blob stand for? I'll go ahead and answer that right now. Blobs are binary large objects. So what we mean by blobs are an opaque set of bytes, things like documents that you might store in your database. All right, so now let me share my desktop. I'll give everyone's screens a second to synchronize. What you should see on your screen is an instance of SQL Server Management Studio. What I'm going to do is take you through an example of how to create a database that makes use of file streams. We're going to make some updates to those file stream objects. And then what we'll do is show you an example of how the integrated nature of those file streams, integrated nature of the features will enable the same types of scenarios that you might use on SQL Server var binary max columns, yet get all the performance benefits of the file system. So what I'm going to do to start with is I'm going to switch over to using the master database. I'm going to drop my test database. You will see that it doesn't exist. What I'm going to do is I'm going to create a database called TestDB. The TestDB database is created on my C drive as specifying where the database files are stored. We've created a file group within the database that will be used to store all of the file objects with the database. So let's start by creating a table. This table is going to be a table where we're going to store insurance claims. Insurance claims the insurance claims table is going to have 3 columns to it. It's going to have a claim ID, an X-ray report, and a version field. Seems like a pretty simple table. What you'll also notice is the X-ray report is stored as a var binary max column, and we've added the file stream storage attribute to indicate that the blobs will be stored within the file system. So let's switch over to using this database. The first thing I'm going to do is I'm going to create a trigger. Now we have this version column stored in the table, and what I want to do is anytime an update happens to the file, so an X-ray report, I want to update the version number so that it automatically increments. Seems like a very simple way to implement versioning. And there we go. I've created a trigger directly integrated with the blob call, or with the file stream call. So let's insert a very simple row. I'm inserting a row where I create a new claim ID. I'm taking a string of text and converting it into var binary max and inserting a version number. Now obviously that column would typically store a document. Maybe it's in this case a photo, or it might even be any other, maybe a video file, etc. But when I retrieve that record back out of the database, or run a simple select statement, what you'll see is I've retrieved the claim ID, the X-ray report, and the version number. Okay, so now we've gotten to the point where we have our blobs stored directly in line with our database. First thing that I'm going to do is I'm going to back up the database. You'll notice that my backup happened very quickly. I backed up the database to a file on my C drive. We're going to make use of that backup later, and so we'll come back to that in a minute. Now let's talk about how we can make some reads and writes to the binary object that we just stored inside the database. I'm going to start by creating a transaction. And the next thing I'm going to do is make use of a new API that we've created called getFileStreamTransactionContext. And what that does is it gets the transaction context for the open transaction, and any subsequent accesses to the blob have to be used within the context, within that particular transaction context. I'll explain this line in a minute. The next thing that I'm going to do is I'm going to retrieve the path name. The path name to the file object that was created is stored as a UNC path that your file system can use, that the kernel driver that the file stream feature uses, to map accesses to those objects through your Win32 APIs. So we've created a test program called FSA Create. It's just a demo program that we've created. I'm going to use this program on my command line to essentially read the X-ray report that's stored in the database. This program will do is take that transaction context and take the path to that file. And what you'll notice when I execute that program at the command line is the contents of that file is read back out in terms of bytes. Now, my app isn't doing anything interesting here, but you can easily imagine how the app could do something different if it was an X-ray image or if it was a video file. It could load your video player, or it could load your picture viewer and load those objects into that application. So now, let me go back, and what I'm going to do is let's make a write to that file. When I make a write to that file, what you'll see is the file has been updated with the text, updated X-ray report. And I'll show you that the write, in fact, did happen. Now let me go back to the database folder itself, and you'll see my database directory here, C:\test, and the file group that I created. If I go into my file group, what you'll see is a directory here that represents those file stream objects that are stored in the database. Now, you may be wondering how I can access this on the file system, for those of you that picked up on the potential security hole here. But what's happening here is I'm running my SQL Server instance as the system, or as the account that I'm currently logged in as, so that I have access to the directories where those file stream objects are located. However, if I was logged in as any other user, that entire directory would be locked down and you wouldn't be able to access the file stream objects. So now let's go back to Management Studio. And I'm going to select back out of that database. And what you'll notice is that X-ray report has been updated with the text that we saw when we ran our command line program against that file stream object. But let's say we made a mistake. If we made a mistake and we need to roll back that transaction, now I can make my rollback transaction call, and you'll see that the command was executed successfully. And if I do my select, my X-ray report has been reverted, and my version number has been restored. So let's go back, and let's this time commit our write. I'm going to create a new transaction. I'll need to get my path name and my transaction context. Now if I go back to the command line, what I will do is make the write. So updated X-ray, as you can see, updated X-ray report is the text that we're going to write to the file stream object. The write was completed. Let me do a select to make sure that the write was completed. It was. And when I commit the transaction, my write has been completed. And you'll notice that the trigger fired appropriately, even though I made the write through the Win32 APIs in my test command line program. But let's say what happens now is my database disk was destroyed, and for whatever reason, I need to restore my database from a backup copy. So I'm going to switch off to the master database. I'm going to drop the test database, and I'm going to restore the test database from my backup that we made earlier in our demo. And you'll notice that the restore happened successfully. And now when I select out of the database, and I get my initial version of the file, which was when we made our backup. So as you can see, what you've seen here is an example of how the file system is being used to store those blobs rather than a var binary column within the database. What that means is when you access that file through the file system, you'll get all the performance benefits of the file system's native performance statistics without incurring the overhead of the SQL Server database engine. So now, if we go back, I'm going to return to the presentation. All right. I'm going to return to the presentation. I want to talk a bit about a few of the limitations that we have in our initial release of file streams. File streams is a feature that we're delivering in SQL Server 2008. The remote storage of those file system objects is not supported, even though they're stored as a UNC path, or accessed through a UNC path. Those file stream objects, must be stored on the same disk locally with the rest of the database. Our snapshot and mirroring capabilities are not supported, but log shipping and a replication are. And then we have a few features that we're building into SQL Server 2008 around transparent encryption and table value parameters that will not be integrated for file stream in SQL Server 2008. We're working towards determining whether or not those features will require integration with file stream for future releases, and it will be largely dependent on customer feedback. So now let me switch gears and talk about our other scenario around the storage of unstructured data. So in those scenarios where your blobs or your unstructured data is stored in a file server or in a dedicated blob store, and your structured data is stored in the SQL Server, there's a lot of complexity that goes in around managing the links and the references that are stored in the database server to the blobs stored in your blob store providers or your file servers. So what the Remote Blob Store API is all about is simplifying the development and the management of applications that store those different types of data in different places. We're creating this API that consists of a native and managed client that you can embed within your applications on the client side and access your structured data through ADO.NET, make use of links that are stored in an abstract way in the database, and use to reference the blobs in a provider-agnostic way in the blob store provider. So if you have a file system as the place where your blobs are stored, the file system provider will be used to manage the retrieval and the storage of blobs in the file system. If you're using EMC Centera, there will be an EMC Centera provider that will handle the specifics of storage and retrieval of those blobs. And the Remote Blob Store API will allow you to access those blobs and those storage, that structured data in a provider-agnostic way. The provider APIs, we expect to supply a number of provider APIs for different storage technologies that Microsoft is delivering, and we're working with other vendors to ensure that providers will be available for other storage systems as well. So what does RBS exactly do, and how does it work? Well, what RBS will essentially do is when a blob needs to be stored, the blob will get stored into the blob store. That's step number one. Say in my X-ray report example, I'll write my X-ray report to my EMC Centera box. The EMC Centera box will return through the provider library and through the client library a handle that will be used to reference the blob later on in your application. The RBS API will do the hard work of maintaining the consistency between, maintaining the link between the database and the blob store, and it will handle garbage collection. The third part of this whole process is to store that handle back into the database. So if I look at an example record, what I will have is my claim ID, a claim date, for example, and then a reference to a blob that will be an opaque object to your application, but will be used by the RBS library to retrieve and access the blobs in the future. Now there's a couple of trade-offs that RBS entails when compared with something like file streams. But what Remote Blob Store really enables is when interoperability is required between different systems that you use to solve different problems, RBS becomes very, very useful. We make no restrictions on what the backend store is. It could be an EMC Centera box as well as a Windows file server. The backend can change without any app changes. All you have to do is swap in the appropriate provider. And then RBS does come with a set of trade-offs. What we guarantee is something that we call link level consistency, so that the links in the database will always remain consistent, will always point to a blob that lives in the blob store, and vice versa. But we can't guarantee things like transactional semantics. We can't guarantee a uniform set of services like backup and restore, because that would depend on the specific characteristics of each of the blob store providers. What the database server will handle in this case is the link consistency and the garbage collection. So to summarize, SQL Server 2008 is offering two new ways of managing and working with your blob data, your unstructured data, things like your documents and multimedia files. The first is something that we're calling file streams. File streams are aimed at improving streaming performance over SQL Server blobs. They'll offer link level consistency and data level consistency, which means integrated services like backup restore and backup restore and transactional semantics. You'll get your integrated administration experience with file streams. With your Remote Blob Store API, you'll get the ability to use external blob stores while you trade off data level consistency, things like transactional semantics, and an integrated administration experience. So now, let's move on. One of the most common scenarios that we observe when you're working with your unstructured data and your structured data alike is the need to be able to search through it and create a full text index over all of that data. We made some big strides in 2005 around our support for full text indexing. In SQL Server 2008, we recognized that even though we made those big strides, there was a big problem. The big problem was that our full text engine lived outside the database engine, and we depended on the Windows Server search infrastructure to deliver the full text index. Well, this presented a couple of problems. First, there was a management and deployment challenge in that you now had to deploy two different components to be able to deliver full text search capabilities. And the second problem was a performance problem. The performance challenge stems from the fact that the two separate engines had to be, you had to interact with those two separate engines separately. So if you did a query where you were going to do a full text query as well as a query against a column in the database, within the same query, the results from the full text query had to be completely spooled over to the database engine before you could do the filtering from the searches against the database tables. Now what we've done in SQL Server 2008 is to fully integrate that full text index engine so that we don't have those performance benefits or our performance challenges or the deployment challenges. What that translates to is queries like the one below on this slide will perform much faster than what you had available to you in SQL Server 2005. So what you'll observe about this query is that you're running a full text query using the contains predicate against a, in this particular case, a resume column. But you're also querying at the same time a specific zip code that is mapped that is mapped as a typical SQL Server column. Because the full text indexing engine is completely integrated with the database engine, the performance benefit, or the performance of this query will substantially outperform the performance of our previous version of SQL Server. And what we have seen in our preliminary testing is performance improvements from anywhere to 2x to 4x, depending on your workloads and your data sets. So let's move on. Let's talk a bit about our spatial support. Actually, before I talk about this, let me double check our question stack and make sure that there's nothing that I should answer right now. I see a few questions around file streams that I will return to at the end of this discussion. So I think everyone seems to be on the same page for now. So I'll keep going and talk a bit about our support for the spatial data type. Now, there was a question that somebody asked whether or not there's going to be a webcast on spatial data type. I'm sure we can work with the webcast team to figure out something that we can do there. But spatial data type is something that's very exciting for SQL Server 2008. We know that location is becoming more and more important to all of your applications. And so what we've done is built in native support for spatial data types. What that means is we've introduced two new data types, geometry and geography. Geometry is really about your 2D data types, and geography is about representing all of the different types of location you could have, multi-dimensional, including X, Y, and Z coordinates, and different labeling schemes. We've introduced a new set of methods, things like intersection, buffering, unions, that all make sense in terms of spatial operations. And we've created a new set of spatial indices to ensure that all the spatial queries, or all the queries that you run against the spatial data types, will perform just as fast as using any other native data type. Our spatial support is fully standard compliant, so applications that are built to take advantage of standards compliant spatial support will continue to work. And then we've also integrated virtual earth capabilities directly into the database so that you can make use of the mapping capabilities of location data. So let's also talk about our XML support. Our XML support, we've upgraded our support for XML from 2005 with a few relatively important updates. There's nothing major here, although we have become fully compliant with the XML schema standard. We have full support for all the capabilities around lax validation and date time. What this translates to is all of the new Office document formats, the new XML-based document formats, will be fully supported in 2008. So if you choose to store your Office 2007 documents into the database in their native form as XML, all of the schema validation logic that those documents depend on will continue to work. We've also introduced a few new features to bring us, again, in line with XML standards around the let clause and support for SQL variables as well. Now finally, I want to move to a few features that revolve around the storage of your structured data. We know that Beyond Relational is about the storage of unstructured data and the use of unstructured data and semi-structured data, but these information-centric applications really make use of structured data as much as they make use of that unstructured data. And so, so there are a number of features that we're building to help manage the storage of unstructured data. The first feature is something called hierarchy ID. I think most people know that if you ask 5 different people how they end up storing and representing hierarchy in the database, you'll get 7 different answers on the best way to do that. Well, hierarchy ID is a very, very common scenario. The storage of hierarchy in the database is a very, very common scenario. Oftentimes you'll have parent-child relationships. You might be storing path names in the database, or you might be just storing a tree of information all organized into a hierarchy but it's very difficult to pull that hierarchy back out of the database when it's stored as rows in a table. So what we're introducing is a notion of hierarchy ID, which includes a set of operators to let you navigate hierarchies among rows in the database. We think this is going to be a very, very important feature for applications. And we think it's going to be a big win because it's a very, very common pain that we hear in the storage of structured data. The second key feature here is to improve upon our user-defined type support from 2005. What we've done is eliminated the 8K limit on user-defined types that existed in 2005 so that your UDTs in SQL Server 2008 can now be of unlimited size. The third feature that we place into this bucket is something we're calling sparse columns and wide tables. Well, sorry, the third and fourth features, called sparse columns and wide tables. The best way to think about sparse columns and wide tables is think about applications like SharePoint. If you're implementing an application like SharePoint, oftentimes one of the key features of those applications is the ability to add columns to your tables dynamically. So if you think about the SharePoint data model, SharePoint stores all of its items in a single table, but users can extend each of those items with their own sets of columns. And to do so, one way to do that would be to go through the data model gymnastics that most applications do today to support the dynamic addition of columns. Well, with SQL Server 2008, what we're doing is introducing a notion of sparse columns and wide tables that will allow the dynamic addition of columns. You can support many, many columns, thousands and thousands of columns, tens of thousands of columns, without affecting the performance of the rest of the items in the database. The final feature to talk about here is something that we're calling filtered indices. So suppose I have a table that's storing many, many different types of data. For example, it might store photos, it might store audio files, it might store video files, and let's suppose that I want to create an index on only a subset of those files. Say, for example, I want to create an index over just the image files. Well, if I'm going to create that index, what I can do in SQL Server 2008 is add a predicate to my create index statements, and all of a sudden what will happen is the subset of rows that match that filter predicate to the index statement will only create an index on the rows that apply to that statement. What that means is you have greater levels of flexibility around your indexing strategies for tables that may contain many, many different types of information. So with that, let me summarize the session. Our goal is to deliver a product in SQL Server 2008 that will make it easier to create and manage these information-centric applications that utilize many different forms of data. I hope that you will watch for SQL Server 2008 CTPs that will be released over the next few months. Most of the features that we talked about today are going to be released in future CTPs, probably CTP 4, CTP 5, and CTP 6 over the next 2 to 3 months. And we look forward to you downloading and using the CTPs to send us your feedback and help us improve how all of these features work. So with that, I'll leave a few next steps here to go visit the site, download CTPs, and send us feedback on what's there. One of the reasons why I'm unable to give you more demos, I know there's a number of people that are asking for more demos, is we're in the process of locking down all these features and delivering all of these features into the product, so demos aren't quite available yet, but they will become more and more available over the next several months. And with that, I'll hand it back over to Heather, who wanted to mention a few things about the webcast. And appreciate all the time that you've spent here. And we'll get to your questions. Actually, maybe we should do our questions first, and then I'll hand it back to Heather. Sorry about that.
Actually, Sean, I would like to launch the evaluation so people can fill it out while you're answering the questions.
Great. Sounds great.
Okay. So I'd also like to remind everyone that you can print a PDF of the slides by going up to the File menu in the upper navigation bar and selecting the Print PDF option. And I'm launching the evaluation right now. You should be seeing it showing up in your slide area in just a moment. All you need to do to fill out the survey is to click on the links that you see in the middle of your screen. We do appreciate your feedback. We read all your comments, and I do encourage you to just take a moment to fill it out before you log off. And with that, I'll go ahead and hand the floor back over to Sean to wrap up with the questions.
Great. So I'll just go. I'll go from the top of the list on down for everyone here. The first question that I have up here is: will hierarchy ID type be supported in SQL Server 2008 Compact Edition? That's a great question. I do not believe that it will be supported in CE. Sorry, I apologize. My screen is doing something funny here. Let me get back. So I do not believe that SQL Server 2008 will be supported. Hierarchy ID will be supported in CE, but I can verify that. My email address should be available in the presentation on the first slide of the presentation. Feel free to email me any follow-up questions, and I'd be more than happy to verify that. The second question I see is related to file streams. Does the usage of file stream require the use of Windows authentication on SQL Server? The answer to that question is no. The usage of file stream is or the security around file stream will be mapped to the access privileges that the SQL Server instance has. So if you're not using Windows authentication, the authentication method that you have into the database will be used to protect the file stream objects. The next question is: can table partitioning be used when using a file stream column in the table? That's a great question. The answer to that question is I believe the answer to that question is no, and we're working towards integrating that in a future version. Again, I can verify that moving forward. I know there was some talk of delivering that in 2008, and I don't believe that we have support for partitioning in 2008. The next question is, let's see. Okay, so the next question is more of a comment around the need for mirroring. One of you has mentioned that the need for mirroring support of file streams is necessary. We are currently seeking more and more feedback on whether the mirroring and whether the mirroring capabilities around file streams are required by customers. We're looking into that now. Your feedback is definitely very much appreciated, and we will. We'll definitely take that into account. Feel free to contact me. I'd be interested to hear about your scenario, your specific scenario, so that we can talk through what alternative options might exist if there are any. The next question is: besides integration with Virtual Earth, what else can I use spatial data? May I install SQL Server 2008 on Server 2003 or Server 2000? I believe SQL Server 2008 will require Windows Server 2003. Based on what else can I use spatial data? I'm not sure I completely understand the question, but the spatial data support that we offer in SQL Server 2008 is it's creating a new data type for support for spatial data. So that in the same way that I use something like an integer or a varchar column, I'll have a spatial column, and then I'll have a set of capabilities over that spatial column, things like union and intersection, so that I can do things like compute the nearest, compute the set of location coordinates within 5 miles of a particular latitude and longitude. What our spatial support is allowing you to do is enable a richer set of querying and capability across spatial specific type functionality. I hope that answers your question. Feel free to follow up with this with another question if I didn't quite answer what you were getting at. The next question is asking me to elaborate on the limitation of file stream objects You mean, okay, so the question is asking me to elaborate on the limitation of file streams in SQL to be located on the database disk. Do I mean any disk on the same server, or do I mean the specific disk? What I mean is the same disk on which your database is located, the database file itself, that is the same disk that the file stream objects must be located on. Because the file streams are created as file groups within that particular database. Now, that disk on which your database might be located could be something like a SAN, which will still be okay, but it needs to appear to the system as a directly attached disk, and it must be co-located with the location of the database file itself. So the next question is, can I give you more details on the virtual Earth integration? The details, essentially what we're offering is integration into the virtual Earth APIs. We will be publishing more content on the virtual Earth support, on our spatial support in 2008 over the next several weeks and several months, so you should definitely look for that. But what we've essentially done is exposed through either a web service, both, and at an API level, a set of APIs that come with virtual Earth in order to implement capabilities like mapping, drawing, and painting onto a map, embeddable controls for your application so that you can embed a map within your application. We do have a demo of the spatial support that we will be making available and making public over the next month or two as we finalize the feature into the SQL Server build. So look for that over the course of the next month or two to get a better glimpse of some of the spatial capabilities that we're planning to offer. The next question is, will Microsoft be providing any applications for editing or digitizing of spatial data? So that's a great question. Once the data is in the database, the editing, I'm assuming what you mean is not necessarily editing of spatial data within the database. I'm assuming what you mean is if spatial data lives outside of the database, can I edit that spatial data and then get that into the database? Most of that will rely on partner products and products outside of the database. And because we chose to be standards compliant with our spatial support, any tools out there for editing and digitization of spatial data that work with standards compliant spatial support will be supported by SQL Server. So the next question I see is, does SQL Server 2008 include improved integration between reporting services and analysis services? The answer to that question is yes. We're making a number of investments in reporting services and analysis services. I suspect that we will have webcasts on our BI capabilities that we're building into 2008, and you should look for those, and you'll be able to get a sense for some of the capabilities that we're building into reporting services and analysis services. I'll give you an example. I'll give you one simple example. Before, SQL Server used to require IIS to deliver the reporting services capabilities through the web service that we exposed. Well, with 2008, we've integrated a web server directly into the box so that if you deploy SQL Server on a machine, whether or not you have IIS on that machine, you'll have a web server ready to go that's running, that will be able to run reporting services and analysis services. Very simple example of some of the steps that we're taking towards integrating those capabilities into the product in a better way. So there's about 3 more questions. I'm going to need to run here in a couple of minutes. So I'll answer these 3 questions. And again, I appreciate everyone's time here and hope everyone is excited about the capabilities we're building into 2008. The last few questions here is, do I have more detailed information about geodata related features? Well, follow up. I encourage you to follow up with me over email. I'd be more than happy to give you more information about the specifics around spatial support. But there's a number of capabilities that we're building into spatial support. It's fully feature rich, and if you have specific questions, I'd be more than happy to answer them. For spatial data, what is the point of reference? The point of reference. I am not sure I understand the question. Maybe you could rephrase or follow up follow-up in my email. If you mean point of reference with specifics to how you interact with spatial data, are geography and geometry types. So geography is using a simple lat-long scheme to be able to access, to be able to interact with different data points. The geometry type allows you to layer whatever, or to utilize whatever coordinate system you really want, depending on the complexity of your application, or depending on the needs of your application. One might be better suited than the other, unless I misunderstood what you meant by point of reference. The last question that I see here is, do I anticipate eliminating the requirement that of co-location on the same disk for file streams? It seems like a significant limitation. The answer to that question is we're investigating that. We don't have any plans or announcements around that, and we will look for that in future versions of SQL Server as we figure out our roadmap around file streams. So with that, I appreciate everyone's time. Thank you very much, and I hope you enjoyed our session here today, and look forward to hearing from you either by email or through your feedback that you send to us after using the product and the beta releases of the product. Take care, everybody, and have a great day.
Thank you very much, Sean, for your presentation today, and thank you all for joining us. Please do take a moment to fill out the survey prior to exiting the session room. You may now disconnect from the audio portion of today's conference.